These are pre-algebra notes for section 4.3, where we will use linear models to make predictions. So our key concept tells us that scatter plots can be used to make predictions about current or future trends. And to do that, we're going to look for corresponding y values for a given x value. So it's going to say, okay, when x is this, what is the output? And we're going to do the same thing when we find the equation of a trend line and find the y value of a given x value. So let's get right to it. Let's review using a graph to write the equation of the line. So we're going to start by finding the slope, and the slope, that takes us back to topic 2. Slope is the rise over the run. So you should remember those words, and you're going to go from a perfect point to a perfect point, and it doesn't matter which ones you use on the graph, just that you go from a perfect point to a perfect point. Now, I can see that I'm going down 2 boxes, so that's negative 2 boxes, and I'm running 1. So my slope is negative 2. And my y-intercept is where the line crosses or touches the y-axis. So this is touching at 9. And when I put it all together, y equals mx plus b. That's y equals negative 2x plus 9. Okay, now we're going to use a scatter plot to make a prediction. So this one tells us to use the trend line of a scatter plot to make a prediction. The scatter plot shows the relationship between the number of people at a water park and the temperature. About how many people should the owners of the park expect at the water park when the outside temperature is 90 degrees Fahrenheit. So we want to look specifically at the temperature being 90 degrees Fahrenheit. So we're going to go over to where it's 90 degrees, and we're going to go up to where it hits that trend line. And it's hitting above 800. So let's say, I don't know, let's say roughly 820, 825, somewhere in there. A little more, let's just say, at 90 degrees Fahrenheit, they should expect we can just make it easy and say 800 people at the water park. We're going to do the same thing here. The scatter plot shows a hiker's elevation above sea level. The equation of the trend line is y equals 7.18x plus 690. Use the equation to predict the hiker's elevation after 150 minutes. Well, I can see 150 minutes right here. And how many does each box count for? Let's see if I have 1, 2, 3, 4, 5, 6 boxes to make 1,500. That means each box counts for 250. So after 1,500, my best estimate would be 1,750. And then if we use the equation, so we're given this equation, y equals 7.18x plus 690. When we plug in 150, that's our x value. We're going to plug that in for x. So 7.18 times the 150, and then add 690. So that's saying 1767. So that's going to be 1,767 feet. So looking at the box, that was a rough estimate, but we want our exact one when we use the equation. Okay. Next says Jean and Martin were investigating a trend in fuel economy in vehicles since 1980. They collected data and created the following graph. So look how close those dots are to the trend line. Step 1 says write an equation for the trend line. So we need to find, I'm going to go from this point to this point. So my rise here, let's see, that would be at 15. So I'm rising 3 and I'm running 10 years because each box represents 5. So my rise is 3/10. Or my rise over my run, I should say. My slope is 3/10, and my y-intercept is where that crosses the y-axis at 15. So my equation would be y equals 3/10 plus 15. If you want to use a decimal, y equals 0.30x plus 15. How many years after 1980 is the year 2025? And it's asking us that because that's how we are measuring years on the x-axis. So 2025, that's 45 years after. What value does that represent? Well, that's my x value. And when we use that equation, y equals 0.30x plus 15, now we're going to take that 45 and plug it in for x. 0.30 times 45 plus 15. Whoops. 0.30 times 45 plus 15 is 28.5. And that is miles per gallon. Okay, the last one says the scatter plot suggests a linear relationship between the temperature and the number of smoothies purchased in thousands. What is the rate of change or the slope that represents a situation? And what does this mean? Okay, so I want to go I'm going to do a perfect point to a perfect point. And those are directly on the graph. So let's see. I'm going to figure out how much is my rise, how much is my run. So my rise goes up 1, 2, 3 boxes, but it looks like each box represents 8. To go from 32 to 40, between 48 and 64 would be 56. So a rise of 24. And my run is 4 boxes, but each box represents 10. So 24 over 40, 4 boxes, each one represents 10. So 4 times 10 is 40. And then when I simplify that, let's see, they're both divisible by 8. So that makes 3/5. So my rise means for every 3 smoothies. Well, we really need to talk about how the temperature changes. When the temperature increases by 5 degrees, smoothie sales increase by 3. And what is the y-intercept of the line that represents this situation? Okay, so this is hitting at 8. Okay, so B is equal to 8. And that just means when the temperature is 0 degrees, $8,000 smoothies are sold. And I'm realizing I need to go up to that one on A and say, when the temperature increases by 5 degrees, smoothie sales increase by 3,000. I did not pay attention to the scale, so that's my bad. So we'll just go back and fix it now. What equation relates the temperature X and the number of people who buy a smoothie? So we've written the slope, we've written the y-intercept. So we'll just put that all together. Y equals 3/5 X plus my y-intercept of 8, or you could use the decimal, 0.60X plus 8. And now we want to use one of those two equations to predict how many smoothies would be sold if the temperature reached 115 degrees. So we must be in Phoenix. So y equals 0.60x plus 8. And then we want to use x equals 115. It gets that hot in some places, and they probably sell a lot of smoothies. So when it's 115 degrees, we get 77 here, but that's 77,000. So they should expect to sell smoothies. When it hits 115 degrees. Okay, so this is a good callback to Unit 2, and make sure you are calculating rise over run when you are finding your slope each time.